A very good afternoon to Madam Adrina, my wireless lecturer, and my fellow students. My name is Satish Kumar, son of Anand, and my ID number is 56213115052. First of all, I'd like to thank Madam Adrina for giving me an opportunity to present about the 8PSK modulator. First of all, what is PSK? PSK stands for phase shifting key, which is a digital modulation scheme that conveys data by modulating the phase of reference signal into the carrier wave. The modulation is carried out by varying the sine and cosine inputs. It is used widely for wireless LANs, Bluetooth communication, and RFID. The phase of the signal can be used in two fundamental ways: by viewing the phase itself as conveying the information, in which case the demodulator must have a reference signal to compare the received signal phase. It also should be viewing the change in phase for conveying information differential schemes. Next, what is 8PSK modulator? The 8PSK modulator is realized as an augmentation of the existing 2BPSK modulator at X bands. In multi-level PSK, more than 2 bits are mapped using different phase angles. In 8PSK, different phase angles are used to represent bits, which also 3 bits. Figure below shows the constellation of 8PSK signal. With 8PSK, 3 bits are encoded, forming 3 bytes and producing 8 different output phases. To encode 8 different phases, the incoming bits are encoded in groups of 3 called bits, which is 2 power of 3 is equal to 8. This is the block diagram of the 8PSK. First of all is the input data, which is Q, I, and C channels. The I channels will flow into the 2 to 4 level converter, and the Q channel also will flow to the 2 to 4 level converter, which will be passed by BAM and enters into the product modulator. For the Q Q channel, it also passes the product modulator and consists of a reference oscillator, and the Q and I will passes to the band pass filter into and combine in the linear summer, and will flow into the band pass filter again, and it produces the 8PSK output. Okay. This is the table for I channel and Q channel, and include the output. This is an example of the I channel and Q channel. Okay. The bit rate in each of 3 channels is divided by 3. The bits in the I and C channel enter the I channel 2 to 4 level converter, and the bits in the Q and C channel enters the Q channel 2 to 4 converter. Essentially, the 2 to 4 converter are parallel input digital to an analog converter. With 2 input bits, 4 output voltage are possible. The I and Q bit determines the polarity of the output analog signal, which is logic 1 equals to positive voltage and the logic 0 equals to negative voltage, whereas the C or the C bit determines the magnitude. For example, logic 1 is equal to 1.307 volt and logic 0 is equal to 0.541 volt. Next is the truth table corresponding output condition for the 2 to 4 level converter. Because the C and C bits can never be the same logic state, the output from the I and Q to 2 level converter can never have the same magnitude, although they can have the same polarity. The output of 2 to 4 level converter is in M array, pulse amplitude modulated PH, where M equals to 4. Next is the example. That's an example question for the 8PSK modulator. For a tri-bit input of Q equals to 0, 1 I equals to 0 and C equals to 0, determine the output phase for the SPSK modulator shown in the figure. The figure solution. The input to the I channel 2 to 4 level converter are I equals to 0 and C equals to 0. From figure 2, the output is negative 0.541 volt. The input to the Q channel converter are Q equals to 0 and C equals to 1. Again from there, the output is negative 1.307 volt. Thus, the two input to the I channel product modulator are negative 0.541 and sin omega Ct. The output is I equals to 0.541 times with the sin omega Ct is equal to 0.541 sin omega Ct. The two input to the Q channel product modulator are negative 1.307 volt and cos omega Ct. The output is, as we refer, Q equal to negative 1.307 times with the cos omega Ct equals to negative 1.307 cos omega Ct. The outputs of the I and Q channel product modulator are combined in the linear summer and produce a modulated output of summer output, which equals to negative 0.541 sin omega Ct minus with 1.307 cos omega Ct, which is equals to 1.541 sin omega Ct minus with 112.5 degree. Thus, this is the table and the diagram of the 8PSK modulator, and when the Q channel I channel is equal to 0 and the C equals to 0, the value is negative 112.5, while when the Q channel 1, I channel 1 and C channel 1, the value is positive 22.5, where the thank you, that's all.